Hello, I would like to perform an electric circuit calculation for a series circuit. That is, two electrical resistors in series, sequentially one right after the other, with an ideal voltage source, which we'll call a battery, and also with ideal wires, where we assume the wires have no electrical resistance. Let's let resistor 1 be 1 ohm, resistor 2 be 5 ohms, and the battery voltage be 12.0 volts. Let's first calculate the total resistance, the electric current flowing through the circuit, the voltage drop across each resistor, and then also the power dissipated by each resistor and the power outputted by the battery. So let's take each of these one at a time. Okay? First of all, let's have a look at the circuit diagram here. Notice the circuit diagram, okay, has the following setup, okay, where the electric current is indeed flowing out of the battery. It's labeled for us, and it goes clockwise, okay? So the direction of the electric current is clockwise. I think through all devices and through all pieces of wire and through the battery itself. Okay? So that's the idea. Now, if that's the electric current, let's take a look at the total resistance. Well, the total resistance is going to be just the sum of each of these resistances, because in series, the total resistance is the sum of each resistance, since the current has to push through all of them. Whether a resistance is upstream or downstream, it's sort of felt by the voltage source. So that means our total is going to equal to R1 plus R2. Now, that's going to be 1 ohm plus 5 ohms, and that should be exactly 6 ohms. Okay, so this is just the total resistance being the sum of each resistance, and that's the traditional arithmetic sum. Okay, so this is our first answer. Okay, B. Find the current flowing in the circuit. Well, the current, that's this I, which we've already labeled, okay, that should be found from Ohm's law. Now notice, if the voltage is 12 volts, then that should equal to delta V divided by, and then the total resistance, which was R total. R total. Okay, hopefully you see that. So let's put the numbers in. The total resistance we just found to be 6.0 ohms, but the voltage is given as 12 volts. So this is 12.0 volts. Okay? And then from this we calculate the current. So 12 divided by 6 is exactly 2.0, and that's amperes. That's the units of electric current that flows in this circuit. Okay? Then we're going to calculate the voltage drop across each resistor. So the voltage drop across each resistor will be the voltage across here and the voltage change across here. So we could call that delta V1 and delta V2. Now let's look at delta V1 and delta V2. The voltage drop across each resistor by Ohm's law should be the current through each resistor. Now the current through each resistor is exactly the same. So that's I, because it's a series circuit. But then the resistance of each resistor is unique to each resistor, and so for delta V1, it's going to be I multiplied by R1, and likewise for voltage 2, it's going to be I times R2. Okay, so we need a resistance of 1.0 ohms for resistor 1, 5.0 ohms for resistor 2. Okay, and then the current, again, is the same in both of these cases. It is that 2.0 amperes, which we already calculated. Now, this calculation is not very difficult. The only reason I'm not going extremely fast is because I keep changing colors. I want you to see how these processes work out. So 2.0 amperes times 1.0 ohms. Amperes times ohms should be volts. So that's 2.0 volts. And look at this. For delta V2, so let me separate that out. That should be 2 times 5, so that should be 10.0 volts. Notice 2.0 volts and 10.0 volts sum up to 12.0 volts. That's the total voltage, the total potential, and another way to say this is the total energy per charge, which is the units of voltage available to the circuit. Calculate the power dissipated by each resistor. Well, we can calculate this in several ways. But I would say the easiest way is probably, given that the current is the same for all devices, we know that power is equal to current squared times resistance. If we want the first power from the first resistor, that's going to be I squared times R1. If we want the power from the second resistor, that's going to be I squared times R2. By the way, I here is like the red color, what we saw in the previous board, but it's just the electric current. So let's put the numbers in. So that's going to be 2.0 amperes squared for each of these because they have the same electric current. And then the resistance, resistor 1, is 1.0 ohms. And then this is 5.0 ohms. So that's 4 times 1, so that's 4. And that's going to be units of watts because it's power. And then for resistor 2, it's going to be, again, 4, but this time times 5, so that's 20 watts. Okay. Notice that means a larger resistance in a series circuit would look brighter in terms of if it was a light bulb. 20 watts. In fact, it's going to be 5 times as bright because it has 5 times the resistance. Thus, it has 5 times the brightness if it was a light bulb. And then finally, calculate the power output by the battery. Well, the power from the battery can be calculated like the current coming out of the battery and the voltage difference across the battery terminals, because that's a reflection of the potential energy per charge that the battery delivers. So it's I time, and by the way, remember I is the same for all devices in the series circuit, times delta V of the battery. So that should be 2.0 amperes times 12.0 volts. Now you'll notice the multiplication of those gives 24 watts. But wait a second, that seems strangely familiar. 24 watts is the same thing as the sum of these two powers. In other words, by conservation of energy, or you could really say conservation of power, which is energy per time, the power that the battery outputs is exactly equal to the sum of the powers dissipated by each of those resistors. As long as we assume ideal battery, ideal wires, this is exactly what you would expect. Okay, that ends this problem for a series circuit calculation. Thank you very much for your attention. Please smash that like button if you enjoy this content. and subscribe to the channel to grow the channel. Please share this within your sphere of influence, and I will look forward to seeing you in the next video.